going to be looking at series and parallel circuits. We're first going to consider two resistors R1 and R2 connected in series. And we're going to find the total resistance of these two resistances in series when you have a current I going through the combined resistance R and you have a voltage V across the resistance R. The current in series remains the same, so you have the same current I flowing through resistors R1 and R2. However, the voltage across the two resistors is shared or divided between them. So what we can say is if the total voltage across the two resistors is V, then V will equal V1 plus V2, where V1 is the voltage across R1 and V2 is the voltage across R2. We know that voltage is equal to current times resistance, so we're going to take this equation for voltage across the two resistors and we're going to express it now in terms of I and R. So voltage V will equal to I times R. V1 will equal to the current I times R1. And V2 will equal current I times R2. We can see that current is common throughout, so they can cancel. So we can see our total resistance in that circuit is equal to R1 plus R2. So that means we add resistances in series. And the effect of that is that then the overall resistance in the circuit increases. We're now going to consider the two resistors R1 and R2 in parallel. And again, we're going to find the total resistance of these two resistors in parallel. So that would be equivalent to resistance R, which will have a current I flowing through it and a voltage V across it. In parallel, the current through the resistors is shared or divided between them depending upon how much resistance they have. So if resistor R1, which was larger than the resistance R2, it would have less current through it than R2. Because remember, current takes the path of least resistance. If the total current through the combined resistance R is I, we can then say that I will equal I1 plus I2, where I1 is the current through resistor R1 and I2 is the current through resistor R2. In parallel, the voltage is the same, so you have the same voltage across R1 and R2. We're now going to use the equation V equals IR, but instead we're going to use it in terms of current and get this expression of current in terms of voltage and resistance. So current I will equal V divided by R. I1 will equal voltage V divided by R1. And I2 will equal voltage V divided by R2. You can see that voltage V is common throughout, so we can cancel it to become 1 over R will equal 1 over R1 plus 1 over R2. So in parallel, we add the reciprocals of the resistance, and that equals 1 divided by R total, or the reciprocal of R total. So when you calculate this, to get R total, you will then need to take the reciprocal of this. So as a result of connecting resistors in parallel, the overall resistance decreases. It's important to know that your value of R will always be less than your values of R1 and R2. And that's a good way of knowing if you've done your calculation correct for working out the total resistance. So when we connect ammeters, so to determine the current through a component, so in this case a light bulb, we will connect it in series because current is the same in series. In series, we know resistances add, so the total resistance in this circuit will be the resistance of the ammeter plus the resistance of the light bulb. For the ammeter to have no effect on the circuit, its resistance should be equal to 0. That means then the total resistance in the circuit will only be due to the resistance in the light bulb. We're now going to look at how we connect voltmeters to measure the voltage across a component, so in this case a light bulb. We connect them in parallel because we know voltage or potential difference is the same in parallel. To find the total resistance in this circuit, we need to use the equation for resistance in parallel. So that is adding the reciprocals of the resistances. So 1 divided by R total, RT, is equal to 1 divided by RV, the resistance of the voltmeter, plus 1 divided by RLB, the resistance of the light bulb. For the voltmeter to have no effect on the circuit, it must draw no current through it, so all the current in the circuit will flow through the light bulb. That means that ideally the voltmeter should have infinite resistance, or actually we should say it's tending towards infinity. If we substitute for infinity for RV, 1 divided by infinity that means will tend towards 0. So 1 divided by RT will then equal 1 divided by the resistance of the light bulb. And that's just simply showing you that the total resistance in the circuit will then just equal the resistance of the light bulb.